All right, I think I'm live now. Can someone confirm in the chat if I'm live and if the audio is perfectly clear? Okay. Deepak says yes. Perfect. Ballet says yes. Perfect. Little bit lag. Is that so? Is that for everyone? All right. So let me just read out the chat. Okay, I think people are already discussing problem C, I think. Okay, cool. Anyways, okay. It's fine. Okay, cool. Cool. Okay. So we are going to be solving problem A, B, C, and D. I think I mentioned that in the title and thumbnail also today. Okay. So I think we should start now. Today's contest was slightly easier, I think, I would say. Okay. So let me just open up the problems. Okay. Cool. And probably by the time we finish the stream, I think system testing will also be done. Okay. All right. Cool. Okay. A little bit of lag. Is that so? Probably it will get better in like 2-3 minutes, I think. Okay. So let's just start. Let's see like what happens. Okay. So let's start with the very first problem. Okay. This is of no use. Okay. Given an array A of any integers, A1 till AN, where AI is not equals to 0, check if you can make this array sorted by using the following operation any number of times. An array is sorted if the elements are arranged in non-decreasing order. Perfect. Select two indexes I and J such that AI and AJ have different signs. In other words, one must be positive and one must be negative. Okay. Swap the signs of A and AJ. For example, if you select AI equals to 3 and AJ equals to -2, they will change to -3 and -2. Okay. So Professor Slim saw that the problem is too easy and isn't worth his time, so he decided to give it to you to solve. Okay. Cool. Let's see like how to solve this problem. Okay. Let's take the very first test case. Okay. Uh, yeah. Let's take the very first test case. So we have 7, 3, 2, -11, -13. Okay, and we have -17 and -23. Okay, now we can make any number of swap operations, but AI should be negative. What is given is that A and AJ have different signs. Okay, so let's see for this one. Okay, we know that since this array has to be non-decreasing, okay, that means it should be what? Increasing. Okay. In order to have this increasing, okay, we need all the negative values in the start and all the positive values in the end. Okay, now we have 4 negative sides. That means the first 4 values will become negative and the next 3 values will be positive. So all you have to do is take these negative signs and put them on the first 4 values. Okay, so it becomes -7, -3, -2, -11, and then we have 13, 17, and 23. Now you need to see if this array is sorted. Okay, if this array is sorted, okay, then the answer is yes, otherwise the answer is no. Okay, since this is not sorted, or is it sorted? Yeah, it is sorted actually. -7 is smaller than -3, -3 is smaller than -2, -2 is smaller than -11, then 13, 17, 23. So the answer of this becomes yes. Board nahi dikh raha. Okay. 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 Perfect. So this is the very first test case. Okay. Let's look at the second test case. Second test case has all the positive values only, so we don't really need to do anything. Let's look at the third case. Okay. In the third case, what we have is we have 71, we have -35, we have 7, we have what? -4, -11, and -25. Okay. No hoga bhaiya. For the very first case, oh, it's no. Why? Am I doing something wrong? Uh, why no? -7, oh, sorry. -2, 11 is actually, okay. In the previous case, -11 is actually smaller than -2. Okay. So, like in the final array was -7, -3, -2, -11, 13, 17, 23. Okay. This was the final array. Okay. So, this -11 is actually smaller than -2. Therefore, the answer for this will be no. Okay. Let's move on to the previous next one. Okay. In this, what we have is we have 71, -35, 7, -4, -11, -25. Okay. In total, we have 4 negative values: -35, -4, -11, -25. So first, we actually take away all the signs. Okay. We make the 71, 35, 7, 4, 11, 25. Now we insert minus sign to the first 4 values. So this becomes negative, 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 negative. And this array is sorted now. So the answer is yes. And that's it. So initially, all you have to do is just make a count variable in which you store the count of all the negative values, make all the values positive now, and then make the first count values as negative. That's it. Okay. Now, let me show you the code as well. Okay. Okay. So this is the code I wrote. I'm pretty sure like someone else might have written easier approach as well. What I'm actually doing here is I just scanned the complete array. While scanning, I just saw which all values are negative. I made a count variable to store all the count of negative values. I made all the values as positive then. Then I made the first count values as negative. Okay. After that, I just checked if the final array now is not decreasing. If it is not decreasing, then the answer becomes yes. Otherwise, the answer becomes no. That's it. Will this case work for this case 0, 0? Okay. As you can see in the problem, it is mentioned that all the values are non-zero. Okay. Where AI is not equal to 0. Okay. So it is already mentioned. Okay. So your case is not valid, says the kitchen. Okay. Okay. Anyways, let's move to problem 2. I think like problem A was pretty easy. Okay. All right. Okay. So in problem B, we are given that Hossam decided to sneak into Hisham's room where he's sleeping and change his laptop's password. He already knows his password, which is a string s of length n. He also knows that there are k special letters of the alphabet. Okay. C1 till CK. Harshit says, "Bhai, aapne." Okay, Harshit, I'll look for your message after the stream. Okay, I'll definitely reply on your message. Okay. 2 pointer approach से TLE मिल रहा है. Okay, 2 pointer से TLE मिल रहा है. Why? No, you won't get a TLE from 2 pointer. Okay, I'm pretty sure like you're doing something wrong. Okay. Yeah, you won't get a TLE. Okay, you're doing something wrong. Okay. All right. Anyways. Okay. Problem B. Okay. So, Husam made a program that can do the following. The program considers the current password s of some length m. Then it finds all positions I such that s of I plus 1 is one of the key special characters. Okay. Then it deletes all of those positions from the password s, even if si is a special character. If there are no positions to delete, then the program displays an error message, which is a very loud noise. Okay. For example, suppose the string s is this and the special characters are b and d. So b is a special character and d is a special character. If we run the program once, the position 1 and 3 will be deleted. Why? Because position 2 is a special character. So position 1 will be deleted and position 3 will be deleted because position 4 is a special character. Okay. Alright. And the string will become bdef. Now again, if you see, d is the special character. So it will delete b. Okay. So it will become def. Now there is no special character before d. Okay. No character before d. Okay. Therefore, it won't be able to delete anything, and this will be the final string. Now, if he is wise, he won't run at the third time, because if he runs at the third time, it will create a very loud noise, which we do not want. Okay. All right. So, how to do this problem? Okay. So let's try the very first test case and see like what is happening. Okay. So in the very first test case, we have I love Slim. Okay, we have I love Slim. Okay. All right, cool. Okay. So if you see, the special character is S. Since this S is a special character, okay, in the very first turn, E will be deleted. So it will become I lov slim. In the second term, V will be deleted. So it will become I lo slim. So similarly, in the next turn, it will be I l slim. In the next one, it will be what? I slim. And in the last one, it will be slim. And now since there is no character before the special character, nothing is deleted. And in total, we took one operation, 2, 3, 4, 5. So the answer for this is 5. Okay. Now, let's take the second test case. Okay. Now, okay. In the second case, if you see, we have J, double O, B, double E, L. And O and E are special characters. Now, since this O is a special character, it will delete this J. Since this O is a special character, it will delete this O. Since this E is a special character, it will delete this B. Since this E is a special character, it will delete this E. Okay. The final string will become what? L. Because this J got deleted. Sorry, it will become OEL. Okay. This J got deleted. This O got deleted. This O stayed. This B got deleted. This E got deleted. This E stayed and this L stayed. In the next turn, this E will delete this O. Will have EL. And hence that's it. So in two operations, we were able to get the final string. So 2 is the answer. Okay. Now how to do this? Let's just remove this and let's take a very generic case. Let's say B is a special character. Okay. And let's consider some cases. Let's say we have 3 times A, then 1B, then okay, let's have 2 times A, then 1B, then 3 times A, and then 1B. Okay. Now, we know that in the very first turn, this B will delete this A. In the second turn, this B will delete this A. So in total, 2 turns will be required to delete these 2 A's. Okay. Now, this B will delete this A in one turn in the very first turn. Okay. This B will delete this A in the second turn. This A will be deleted in the third turn. And this B will delete this B in the fourth turn. If you see, all the characters after this are already deleted. So the answer for this becomes 4. Because in the first 2 turns, this and this got deleted. In the third turn, this got deleted. And in the fourth turn, this got deleted. And the final string became B only. Okay. And 4 operations were required. Technically, if you see, this B, okay, this B could delete 4 values. This B could delete 2 values. Okay. Since this B could delete more values, okay, that means this B, like all the values deleted by this would stay for a longer time than the values deleted by this. Okay, so this would dominate. But if the case was opposite, let's say, if it was A, B, and let's say this. If you see, this B will delete these 4 A's. This B will delete this A and this B. So 2 characters. Okay. These 2 will be deleted in 2 seconds. These 4 will be deleted in 4 seconds. Hence the answer becomes 4. And that is how you have to. Okay. So basically, if it was, let's say, some characters were, let's say 2 characters were here. Then we had a B. Then we had what? 2 more characters, let's say. Then we again had a B. Then we had like 1 more character, let's say. Then we had a B. Okay. Then we had 3 more characters and then we had a B. Now, this B will require 2 operations to delete these 2 characters. This B will require 3 operations to delete these 2 characters plus this B character. So 3. this B will require two operations to delete this one character and this B. This B will require four operations to delete these three values and this B. Okay. Now, if you see maximum values this 4, therefore this will be the answer. The reason is because by the time this B deletes all these values, everything before this will already be deleted. Okay. And that's it. Like all you had to do was just find the maximum of these. That's it. Okay. Let me just show the code as well. There is one case that you might want to understand. That is A, B, A, B. Let's say this one. If you see in the first operation, okay, the answer for this would be these three A's will be deleted by this B in 3 minutes. These two values will be deleted by this B in 2 seconds. Okay. Now if you see, this B deletes this A in the very first second. Okay. And in the very first second, this B deletes this A in the... Okay. Now the updated string becomes A, B, B. In the next turn, this B will delete this A, this B will delete this B. So essentially, by the time this B deleted two characters, this B could also delete two characters only. And after that, all the characters after these two characters were left and this B was left. So we had one A and one B. And now one operation would be required, okay, to delete this A. So in total, 3 operations. That's it. Okay. Again, pretty easy problem. Let me just show my code as well. Okay. Okay, so this is the code that I wrote. Okay. So what I'm actually doing is I first scanned the complete string. Okay. After that, I took K, which is the number of special characters. Okay. I made an array of 26 because we have 26 lowercase characters in total. Okay. Then I scanned all these special characters, marked all these special characters equals to 1 in this array. Okay. Then I have this count variable, this answer variable. What I'm actually doing is I'm finding all the values before any special characters. Okay. So if let's say we had a special character B here and there were 4 values and then B here. Okay. I'll actually get 5 in the count. But if before this B I only had 3 characters, then I'll get 3 in the count. Okay, because I'm starting from 0. Okay, but whenever I get a special character, I start from 1. Because I need to count that special character as well for my next turn. Okay, so whenever I get a special character, okay, whenever my M of SFI minus A, basically the current character, if that character is a special character, then I see the count of values till I have till now and the maximum answer I've got. Whichever is the maximum becomes my answer and count starts from 1. The reason for count starting from 1 is because I need to count this special character also for my next character. Okay. And yeah, that's it. Okay. And in the end, you just have to delete answer. That's it. Again, I'm pretty sure like everybody got this problem now. Okay. And I think we can move on to problem C. Okay. A 4 times A B A B wala case pe answer 2 hona chahiye na, because after that the other will also get B will also get deleted. Yes, the other B will get deleted, but all the previous values will be deleted by the next B now. Last occurrence of special character, first special character plus 1 हो सकता है क्या? Last occurrence of special character minus first. No, you can't do that. C हुआ but N भी नहीं है. ऐसा क्यों भैया? बहुत demotivated लग रहा. That shouldn't have been the case. I think I don't remember C. Okay, if you're able to DC, then like that's really nice, and I think like you should have been able to do A and B. I think you need to concentrate a little more. Okay, that's it. Like if you're able to do C, you definitely must be able to do A and B. Okay, cool. Let's move to problem C now. Okay, I see only 15 likes to the stream. Do like the stream, guys. Okay. Like it should be at least 50 by now. Okay, let's shall we start with problem C? If anyone has any issues with problem A or B, they can ask now, or else I'll start with problem B. Problem C. Okay, let's start with problem C now. Okay. While searching for the pizza, baby Hossam came across two permutations A and B of length n. Okay. So we have two permutations. Okay, we are dealing with permutations. Permutations. Okay. And we have two permutations A and B. Okay. Now recall A. We have two permutations A and B. Okay. Now recall that a permutation. Okay, this is just the definition of permutation. Okay. Baby Hossam forgot about the pizza and started playing around with the two permutations. While he was playing with them, some elements of the first permutation got mixed up with some elements of the second permutation, and to his surprise, those elements also formed a permutation of size z. Okay, now specifically, he mixed up the permutations to form a new array C in the following way. For each I, he either made Ci equals to Ai or Ci equals to Bi. The array C is a permutation. So basically, what is happening is, let me just take the, okay, let's read this paragraph also. You know permutations A and B and values at some positions in C. Please count the number of values different permutations C that are consistent with the described process and the given values. Since the answer can be large, printed modulo 10 to the power 9 plus 7. Okay. Okay, cool. Okay. Now, let's see. Let's take the very first test case. So, let's see what is A. Our A is 1, 2, 3, 4, 5, 6, 7. Okay. Our B is 2, 3, 1, 7, 6, 5, 4. And our C is 2, 0, 1, 0, 0, 0, 0. Okay. Now, let's see how to solve this. Okay. We already know for this position that we have a 2. For this position, we might have a 2 or 3. Here we already have a 1. For this position, okay, we can have either 4 or 7. Okay. For this position, we can either have 5 or 6. Again, for this position, we can either have 6 or 5. And for this position, we can either have 7 or 4. Now, if you see, we already have a 2 in this permutation. Since we already have a 2 in this permutation, this value will be 3. Because we cannot have another 2 here. So this is fixed now. We have a 3 here. But if you see 4, 7, 5, 6, the left values are 4, 7, 4, 5, 6, and 7. And if you see 4, 7 is present either here or here. Similarly, 5, 6 is either present here or here. Okay. So if you see, I can either have 4 here, then 7 will be present here. Or I can either have 7 here or 4 will be present here. Similarly, I can either have 5 here, then 6 will be present here. Or I can have 6 present here, 5 will be present here. Similarly, here also 5, 6, 6, 5. So in total, we had 4 ways and the answer is 4. You see, the answer for the very first test case is 4. Okay. Now, in order to explain like how we need to do this, let me take a good test case. Okay. Let's take which one? Let's take the fourth test case. Okay. There are many ways of doing this problem. Okay. Okay. So we have our A is actually equals to 1, 6, 4, 7, 2, 3, 8, and 5. Sorry. B is actually equals to 3, 2, 8, 1, 4, 5, 6, and 7. Okay. And C is actually equals to 1. Then we don't have any value here, Then we have a 7. We don't have any value here. We have a 3 here. We don't have any value here. And we have a 5 here. Now, if you see, 1, 3, 7, and 5 are already done. Okay. The rest values are 2, 4, 6, and 8. Okay. Now, if you see, this value can have 2 or 6. This value can either have 4 or 8. This value can either have 2 or 4. This value can either have 8 or 6. And if you see, none of these values have already occurred. That means 2 is dependent upon 6. 6 is further dependent upon 8, and 8 is further dependent upon 4, and 4 is further dependent upon 2. Which means if I fix any of these 4 values, all the other values will also become fixed. Okay, and for the very first value, I have two options. I can either have 2 here or 6 here. If I have 2 here, then since I have a 2 here, I'll actually make 4 here. Now, since 4 is also done, I'll actually get an 8 here. And since 8 is also done, I'll have a 6 here. Similarly, if I remove these, and instead of a 2, I write 6 here. I can, since 6 is already done now, I can actually place 8 here. Since 8 is done, I can place 4 here. Since 4 is done, I can place 2 here. That's okay. So what you had to do for all the remaining values, you had to see how many cycles you can get. Whatever is the number of cycles, 2 to the power number of cycles is the answer. Because for every cycle, you can actually have two options. Either take any one value or the other value, and then all the other values will become fixed. Because similarly in this one, we had one cycle. Okay, if you fix any of the one values for any index, all the other values become fixed. Okay. Okay, let me take another test case, okay, in which the answer is greater than 4. Okay. So if I take which one? I need answer equals to 4. 4 is actually for the first test case only. So let's take the first test case. So we had A as 1, 2, 3, 4, 5, 6, 7. B as 2, 3, 1, 7, 6, 5 and 4. And C was actually equals to 2, no value for this one, 1 here, no. Okay, cool. Now, let's see what is happening. So we know that 1 and 2 are already done. The rest values are 3, 4, 5, 6, 7. Okay. Let's come at the very first one. This says that I can either have 2 or 3. Since 2 is already done, I can say that I'll actually place 3 here, and now I can assume that 3 is also done. Now the rest values are I can either have 4 or 7. None of the 4 or 7 is done. Similarly for this one, none of the 5 or 6 is done. Similarly for this one, none of the 6 or 5 is done. None of the 7 or 4 is done. So let's try to make cycles now. This value says either have a 4 or have a 7. So basically 4 is dependent upon 7. This value says that 5 is dependent upon 6. This value says that 6 is dependent upon 5. This value says that 7 is dependent upon 4. So in turn, if you see, we have two cycles. For every cycle, if you fix any one value, the other value will automatically become fixed. So this cycle will give me 2 ways. This cycle will give me 2 ways. The answer will be 2 into 2, which is 4. Okay. And that's the complete problem. Okay, that is how you have to solve it. Now, there are multiple ways to implement this. I actually did this using disjoint set. If you haven't read about disjoint set, maybe you can watch any video about disjoint set. There's a very good video of Tushar Roy. I myself learned from that. You can watch that. Or you can actually do this using simple DFS also. Okay, DFS in turn, in DFS, you are actually kind of implementing disjoint set only. Okay. So I'll show you my code, like what I did. Or should I also explain like disjoint set in a very faster way? So we had 3, 2, 6, 7. Okay, what disjoint sets are actually is, we actually, first what we do is, let's say we had 1, 2, 3, 4, 5, 6, 7 and 8. Or let's say till 7 only. Let's say we want to say that 3 and 4 belong to the same set. How we can say that? We knew that 1, 2 and 3 are already done. We could say that 1, 2 and 3 belong to the same set. So what you have to do is, you just have to say that 1, 2 and 3 now belong to the same set. This is done using union. Okay. You make them in the same set. And also make sure that, let's say this one is the parent of this complete set. So this one is the parent of this complete set. After that, let's say you wanted to say that 4 and 7 belong to one set. 4 and 7 belong to one set. And let's say 4 is the parent. Similarly, for the next one, let's say 5 and 6 belong to the same set. Okay, so this is one set, and let's say 5 is the parent. This set had all the values which are already fixed. These didn't have any fixed values. So 2 for this, 2 for this, 2 into 2 makes 4. That is how you have to do using this set. I'll quickly show my implementation. Okay, and maybe you can try to understand that one, or maybe look for a better code. Okay, my code is pretty lengthy, I would say. Okay, so this is the code. This is just general implementation of result set. I just copied it. I have a file in which I've written the complete result set implementation. You can also make use of this one. I wrote this myself a very long time back. Okay. Okay, what I'm actually doing here is, first for every value, I'm making a set of its own. Then after getting Ci, okay, I make a union of Ai and Bi, because through this 1 and 2 become dependent. Okay. Through this 2 and 3 become dependent. Through this 3 and 1 become dependent, and so on. After that, for every value in Ci, okay, I find the parent and I erase that value from my map, because this M actually had all the parents. Okay, all the parents of every set. So basically, this size of this M was the total number of sets I had. Okay, and I need to remove that set which actually contains all the fixed values. So in order to do that, I just said that whenever I have a Ci or Ai is equal to Bi, then I can just erase that value from my map, and in the end, whatever is the size of M, my answer will be 2 to the power size of that map. Okay, and don't forget to add modulo as well. That. Okay, again, pretty easy. Becomes a lot easier if you already know like what disjoint sets are. Okay, you could do the same thing using DFS also, but doesn't really matter. Okay. Okay. I hope this is also clear to everyone now, and we can move forward to problem D. All right. So this is problem D. I still see only 26 likes. Why are people not liking the stream? Do like the stream, guys. That actually tells me like, should I make more videos? Okay. Let's see if system testing is complete. Yeah, system testing is almost complete, 96%. Okay. Okay. Let's start with the D problem now. Okay. They love equilateral triangles and want to create n equilateral triangles on the grid by adding some straight lines. The triangles must all be empty from the inside. Okay. You're allowed to add straight lines parallel to the edges of the hexagons. Given in, what is the minimum number of lines you need to add to create at least n equilateral triangles as described? Okay. So basically, you have an infinite grid of hexagons. Okay, regular hexagons. Okay. What you need to do is you need to find how many lines are required. Okay, in order to have at least n number of equilateral triangles. Okay. Now. Okay. Okay, so let's see. Whenever you made the first line, I'll actually explain this complete through the picture only, I think. Okay, because that's kind of difficult to explain using the diagram. I don't think I'll be able to make this big diagram. Okay, so I'll try to explain from here. Whenever you make the very first diagonal, okay, you get zero rectangles, zero triangles. Okay, but if you make the second one, you actually get two equilateral triangles. Okay. Now, in the next one, what we have to do was, okay, the next one, if you make the third line straight line, you actually get 6 equilateral triangles. Okay. Now, one thing to notice is that all the hexagons around this hexagon, this one, this one, this one, this one, and this one remained unaffected. But all the hexagons which are neighbors of these hexagons got affected. This got affected, this got affected, this got affected, this got affected, and the one above this also got affected. Okay. Now, that means it is better in the next turn to actually get some more equilateral triangles from either this one or this one or this one or this one. Let's say we chose this hexagon. If we chose this hexagon, the next line that we need to make in order to get more equilateral triangles would be a line like this. I hope my pointer is visible to everyone. A line like this. And now if you see, there are three type of lines. The first line is this line. The second line is this one. The third line is this one. And when I made a line like this, okay, like this, it actually made two equilateral triangles with the straight line and two equilateral triangles with this one. Okay. Similarly, after this one, if you try to make any other line, okay, let's say if you wanted to make this line, this straight line, it would actually make two equilateral triangles with this one, two equilateral triangles with this one, and two equilateral triangles with the line that we already made. Okay, because whenever you are making a rectangle, okay, one side is of hexagon, one side is from one line, and the other side is also from one line. Okay, and whenever you are making one line, it actually, whenever, if you have this hexagon, okay, and if you made one line, it actually divided this hexagon into two parts. Now you can make use of this line and this line. When you make a line like this, it actually makes two equilateral triangles with this line. Okay, and whenever you make a line like this, sorry, not like this, a line like this, it makes two equilateral triangles with this one with this one and one with this one. Basically, with this line, it made two equilateral triangles. Okay, so what we have is we have three different types of lines. Okay, three types of lines, and whenever you make one extra line, it actually makes two equilateral triangles with every line. Okay, so let's say I had a count of line 1. Okay, let's say line 1, and I had a count of line 2. Let's say line 1 is this, line 2 is this, and line 3 is this. Okay, this is line 1, this is line 2, and this is line 3. Now, when I make line 3, the number of triangles made by this line would be summation of line 1 plus line 2 times 2, because with every line it is making two equilateral triangles. Okay, so basically, essentially, if you have, let's say, already made, let's say, answer of n minus 1 actually stored all the lines you could make using n minus 1 lines. Now, in answer of n, when you are making the nth line, okay, and let's say the nth line is of type 3, okay, line 3 is of type 3. So the answer for this will be all the triangles you could get from answer of n minus 1 plus the number of lines you had of type 1 plus the number of lines you had of type 2, okay, times 2. This is for answer n. And that's it. Okay, and all these lines will be made in a round robin manner. So basically, first you'll make this line, then you'll make this line, and then you'll make this line. That's it. Okay, let me show the code as well. That's all you had to do. Okay, there's some observation that you need for this problem. I'll quickly show the code. Maybe it gets easier to understand with that. Okay. Again, like there's nothing much to explain in this one. Okay, you just need some observation. Okay, so basically what I'm doing is I have what? Answer 1 is equals to 0, because when I make one line with the very first line, okay, I don't get any triangles. Okay, and since I've already made one line, I made that line was equals to of type 1. Okay, so line 1 equals to 1, that the count of line 1s is 1. Okay, count of lines of type 0 is 0, count of lines of type 2 is 0. Now I'm starting from I equals to 2 till 10 to the power 5. Okay. What I'm actually doing is my answer I will actually be equals to answer of I minus 1, all the equilateral triangles that I could make before, plus, okay, plus if my current line is of type 1, if my current line is of type 1, I need to add all my lines of type 0 and type 2, multiply them by 2 and add it to the answer. And also I need to increment my line 1 because I've made another line of type 1 now. Sorry. And similarly the other two cases as well. Through this you would actually get all the equilateral triangles you could get with any number of lines. Okay. After that, it's pretty easy. Like, you're given an n, you just need to find the lower bound of this n in this answer. This answer vector is already sorted because the number of equilateral triangles will keep on increasing with number of lines. Okay. Whatever index you get, subtract that with the starting index, answer dot begin. Okay, and this will give you the like index of that particular value. Okay, and that's it. That's all you have to do for problem D. Again, like pretty easy problem. You just needed some observation skills with this one, and that's it. And with this, I think we are done with problem A, B, C, and D. Okay. If anyone has any problems, okay, they can just let me know. I'll answer them. Else, we can end the stream. Okay. Does anyone has any problems with any problem or anything in general? Okay, I can just answer them for a minute. Okay. I think I'm good to end the stream now. If anyone has any problem, they can just comment down in the video. Yeah, that's it. Do like the stream, guys, and also subscribe to the channel if you want any more such videos. The next contest is on. Let me see. It's on 8th. I'm not sure if I'll be able to give this one. I might be busy for this one. Okay, but I'll definitely give this Div-4 for you guys. Okay, and this one as well. Okay, so yeah, that's it. Let's meet in the next stream. Bye bye.